Hi, good afternoon. So, I'll first take a question today and then we will continue with what we were doing. It says, show that in finding arithmetic mean of 100 readings on temperature, it does not matter whether it is measured in centigrade or Fahrenheit, but it matters in finding geometric mean. This is a 10 marks question. Ten marks question. Let us try to analyze the question and answer this. Before I go ahead and I try to answer this question, हम क्या कर सकते हैं ना? We can go ahead and we can first of all try to do it with two observations. Let me just explain you what this means. Once the interpretation is clear, then you can go ahead and do it for a general case also. And then you can go ahead and you can do it for 10 or 100 observation or any n number of observations also. So first of all, this is a basic known fact. So conversion formula. This is actually a question from the book S.C. Gupta, S.C. Gupta of statistics, right? In mean median mode, this question is a known question. Okay. So we know that the conversion formula is Fahrenheit is equal to 9 by 5 centigrade plus 32 degree. What I want to go ahead and I want to do is, so as I told you, पहले मैं दो observation के साथ, I will show you with two observation, and then we can go ahead and we can proceed it to many observations, right? So if I just consider, you don't have to show two observations. I am showing you for the purpose of explaining. So consider two observations. Okay. Two observations means that there is a thermometer, right? This thermometer is giving you temperature in centigrade, right? And once it has given you a temperature of 20 degrees Celsius, and the other time it has given you a temperature of 30 degrees Celsius. So it has given you two temperature in centigrade. This is what it is saying. That there is, so you are going ahead and you are getting in centigrade from the first thermometer. Okay. Now what we can do is we can find the average. So if I try to find the average in this case, what is going to go ahead and happen? 20 plus 30 by 2. This is going to be 50 by 2, which is going to be 25 degrees Celsius. So which means that this thermometer tells us that so from the observations we have got in this thermometer, we understand that the average temperature is 25 degree centigrade. Now what we can do is we can take another thermometer. This thermometer is giving the corresponding values in Fahrenheit. Same ही temperature measure कर रहा है, but it is measuring in Fahrenheit. So if I were to convert 20 degrees, in case of Fahrenheit, what will be my formula? 9 by 5 centigrade plus 32. So this will be 9 by 5 into 20 plus 32. So this is going to be 9 into 4 plus 32. That means this will be 9 into 27, 36 plus 32. So this is going to be 68. So this means that the first observation I will be getting will be 68 Fahrenheit. This will be 68 Fahrenheit. Is this clear? Now, what we can go ahead and we can do is that we can now similarly see what happens if I have 30 degree, right? So 30 degrees Celsius is going to go ahead and is going to mean, again, I am going to use the same conversion, 9 by 5 into 30 plus 32. So this is going to be 9 into 6 plus 32. So 9 into 6 is 54. plus 32, and this is going to give me 456, 86 Fahrenheit. Right. Now I need to see that what is going to be, so these are the two observations in this thermometer. Now I want to see what is the average here. So if I find the average, I will get 68 plus 86 divided by 2. Right? So this is going to be 8, 9, 10, 11, 12, 13, 14. And this is going to be 154 by 2. That means that this is going to be 77 Fahrenheit. So which means that the average temperature of this Celsius is 25 degrees Celsius and the average temperature in Fahrenheit, that is 77 Fahrenheit. Okay. Now, if I look whether these two things are the same or not, is 25 degree and 77 Fahrenheit same or not, right? So I can also go ahead and I can also check that. How can I check it? Very simple. Fahrenheit again will be 9 by 5 Celsius plus 32. So 9 by 5 into 25 plus 32. So this is going to be 9 into 5 plus 32. So this is going to be 45 plus 32 and this is going to be 77, which is exactly what I am getting. So it means that when I find the arithmetic mean, the two observations that we have, they are absolutely symmetric. Symmetric माने एकदम same आ रही हैं, कुछ भी अलग नहीं आ रहा है. We are getting exactly the same value. Now what we can go ahead and do is, we can find the geometric mean. So if I try to find the geometric mean, what is going to happen here? Well, I am going to get 20 into 30 to the power 1 by 2 under root, right? That's going to be the GM, right? GM is nothing but A into B to the power half. If there are 3 observations, to the power 1 by 3 and so on and so forth. Now, if I try to find the under root of, so this is going to be 600 under root. So 10 root 6, right? So if I try to find the under root of 600, I will go ahead and get 24.49 Celsius. Let us try to find the GM of this temperature that we have found out. So 68 into 86 under root. So GM will be 68 into 86 under root. Right? 68 into 86 under root. So 68 into 86 is giving me 5848. And I just do their under root. So under root of 5848. And this is giving me 76.47 Fahrenheit. This is giving me 76.47 Fahrenheit. Right? Now, the question here is that if I do a conversion, right? If I go ahead and if I find out this in terms of Fahrenheit, what is going to go ahead and happen? So I will get 9 by 5, 24.49 plus 32, right? So 24.49 divided by 5 into 9 plus 32. This is going to go ahead and this is going to give me 76.08. Which means that first thing that we observe here is that it is going to be not exact but approximate. And one reason that we see here is, of course, that there is, the presence of decimals here, and that decimal presence is going ahead and making the conversion inappropriate, right? A bit here and there. But still, if you notice, they are close enough, right? So that is the first aspect here when we try to go ahead and when we try to do it via conversion. When I try to go ahead and when I try to convert the Celsius into Fahrenheit using the same formula, we go ahead and we get the same answer, approximately the same answer here also. And here definitely we are able to get exactly the same answer using the conversion part. That's the first aspect. Now, try to understand this thing. It says that it does not matter whether it is measured in centigrade or Fahrenheit, but it matters in finding the GM. So now what the question is asking us to do? It is saying that when we find the arithmetic mean, right, then this does not matter whether it is centigrade or Fahrenheit. Whether we began with centigrade or Fahrenheit, it does not really matter when we talk about the AM. But when we talk about the geometric mean, then this matters, right? It is important to us whether we have got this aspect in terms of AM or in terms of centigrade or Fahrenheit. Now, how do we go ahead and how do we prove this part? So one thing that we need to go ahead and understand is that whenever arithmetic mean is involved, whenever arithmetic mean of some observations is involved, then supposedly, for example, if I go ahead and I do x1 plus x2 plus, suppose there are n observations, and suppose their arithmetic mean is x bar. Then when we go ahead and when we scale these observations and we also change their, we go ahead and we also change their origin. So we are multiplying with something and we are also adding something, plus C x2 plus D plus C x3 plus D and so on, plus C xn plus D divided by n. We will notice that we will get C x1 plus x2 and so on xn plus nd divided by n, right? So this will give me C x1 plus x2 and so on till xn by n plus d, and this will simply give me C x bar plus d. It means that whenever individual observations are scaled and the origin is changed, right, then the mean will also be scaled and its origin will also be changed. Here, of course, for our case, when we are doing from centigrade to Fahrenheit and all, then we know that the value of this C was 9 by 5 and the value of D was 32. But when these individuals are scaled and multiplied and the origin is changed, then that is going to happen for the mean value also. Now let us try to go ahead and do a similar thing for GM. So suppose I represent that the initial GM is x1 into x2 into x3 till xn under root to the power 1 by n, not under root, to the power 1 by n. And now I go ahead and I scale each observation with C and I add D to it. I scale each observation with C and I add D to it. And I keep doing this. And then I find the nth root, right? Now, you will notice that the term that I will be getting inside is going to be a very complex term. So what is going to happen is, this is going, so suppose, that is why I wanted to show with two observations. So suppose there are just two observations to begin with. This is just under root here and under root here. You will observe that I will get C x1 x2, C square x1 x2 plus CD plus DC x2 plus, this is going to be C square x1 x2 plus C D x1 plus C D x2 plus D square to the power 1 by 2, to the power 1 by 2, right? Now, first of all, I cannot take them separately. But if I really try to do something along it, what is going to happen is, so since I know that x1 into x2 under root is the original GM, I will get that x1 into x2 will be original GM whole square. This is my new GM, GM new. And GM new is going to be C square, original GM whole square plus C, if I take CD common, x1 plus x2 plus D square to the power 1 by 2. So the new GM is not just original GM scaled and added. Either dekho. Here what is happening is that the new AM is also the old AM multiplied and added, right? So each observation was scaled by C and D was added. So here also each observation is scaled by C and D is added. But here when each observation is scaled by C and D is added, each observation is scaled by C and D is added, and I try and find the under root of that, then I am not able to go ahead and get it in the format that, okay, each observation will be scaled and then you will get the old GM and then there will be some, some part of that addition of the origin. Right? So it is of a very different format. I am not able to get that format here. Right? And that is exactly what this is meaning, that it is going to go ahead and it is not going to be that just using the original GM, you are able to go ahead and scale that and add something to it and you will get the new GM, which is very much true when you go ahead and when you do the new AM. Right? So therefore here conversion is easy, right? Here if I go ahead and I have that, okay, my conversion is 9 by 5 and 32, right? And suppose my X bar is the temperature in centigrade and I add 32 to it and I multiply it with 9 by 5, I will get my temperature in Fahrenheit. Average temperature in Fahrenheit. So that conversion is simply change of scale and origin. But here, if I want my temperature in Fahrenheit, then it is not that, right? Then it is this big thing that I derived, right? And hence it can give me separate answer. It's not just going ahead and multiplying with a number and adding something to it. अगर हर ऑब्जर्वेशन मल्टीप्लाई और ऐड हो रहा है तो वो नहीं होगा कि जो फाइनल जीएम आएगा वो भी एक नंबर से मल्टीप्लाई हो जाएगा और ऐड हो जाएगा. दैट इज नॉट व्हाट विल हैपन इन दिस केस, right? That is what the question is going ahead and asking you. That's what the question is all about, right? That the new GM, that means the GM in Fahrenheit is not always equal to the GM in the Celsius multiplied with 9 by 5 plus 32. No, this is the big formula that we have gone ahead and we have derived, right? So the conversion is not that simple in case of GM. Now I have shown you with n observation, although with just 2 observation, we were able to go ahead and we were able to get close enough answers. But with n observation, I have shown you a general formula and I have proved it to you that it does not really go ahead and happen, right? So now you can also go ahead and do it for 10 observation or 100 observation. Instead of n, you can take it at 100, right? So it was a good question to understand how AM and GM work. Okay. And it was a 10 marks question, so I am expecting you to go ahead and write a proper answer for it. Explain properly how change of scale and origin affect AM and GM. Usko proper, you can go ahead and do it using a generalized case, and then you can do it for 100 observation.